So here in section 3.5, we're going to look at tree diagrams and Venn diagrams and how they can be used in helping analyze multi-step experiments. Let's first look at a tree diagram. So we've got a bowl containing 5 red and 3 white marbles. We're going to draw 2 marbles with replacement, and we want to know what's the probability they are the same color. Now, we solved this problem earlier, but we did it with the multiplication rule. And tree diagrams actually use the multiplication and the addition rules simultaneously. Let me show you how that works, but first let's draw a picture of our situation. So there is our bowl of marbles, and you see 5 red ones, 3 white ones, 8 total. So let's go ahead and get our tree diagram going here. So on the first draw, you can draw either a red or a white. And then if you draw red first, on the second draw, which is the second level of the tree, you can draw red or a white. If you draw a white first, your second draw could either be red or white. And then what we do is we put the probability associated with each draw on the branches. So for your first draw and your second draw, so for first draw, probability of drawing a red, well, there are 5 red ones out of 8 total. Desired out of total, 5/8. Probability of drawing a white, 3 white ones out of 8 total, 3/8. And then notice how 5/8 and 3/8 add to 8/8 or 1. So every split, the probabilities have to add to 1. Now, what we do is, if we take this branch, we take one of these red marbles and we draw it out. But it draws with replacement, so we are going to put that back in. So we're going to end up with still our 5 red marbles and 3 white marbles again. So on the second draw, my chances of drawing a red are still 5/8 and white still 3/8. And the same down here if I draw white first, 5/8, 3/8. So my outcomes are red first, red second, that's red, red, red followed by white, red, white, white followed by red, white, red, or 2 white marbles. Now this is an AND probability. This is red on the first and red on the second. And remember, AND probabilities, you multiply. So we multiply the probability of red on the first and red on the second, given that we're starting from red on the first. So we're going to multiply down the branches. 5/8 times 5/8. And that's from multiplication rule. So 25 out of 64. And then we do the same here. 5/8 times 3/8. Which will be 15 out of 64. And then 3/8 times 5/8, another 15 out of 64. And then 2 whites, 3/8 times 3/8. Which is 9 out of 64. And if you add these up here, so 25 and 15 is 40, 55, 64, you get 64 out of 64, which is 1. And that's a double check that you've done everything correctly. So now we want to know what's the probability of same color. So probability of the same color, so there's 2 ways to get the same color. You could get 2 reds or 2 whites. So this is red, red or white, white. And remember, OR probabilities, you add and subtract out the overlap. Well, there is no overlap between those outcomes. If you've got 2 reds, you don't have 2 whites. So probability of red and red is 25 out of 64 plus probability of white and white, 9 out of 64, which is 34 out of 64. And that's what we got previously.